If you don't have to deal with a lot of this stuff often, it's probably more fun to just write the code and not use something like this. Whereas if you're sick of solving the same problem over again, like we've written a RabbitMQ consumer that writes to Kafka and removes the field foo. And then we've got another service that reads from NATs and then it writes out to an S3 bucket and it targy zips the files. If you've written that same app a million times and you're getting fed up with it, then it's for those people. People who are in that space and they're sick of working on the boring junk that they're being asked to do by their data science department.
Big thanks to our partners Linode, Fastly, and LaunchDarkly. We love Linode. They keep it fast and simple. Check them out at linode.com/changelog. Our bandwidth is provided by Fastly. Learn more at fastly.com and get your feature flags powered by LaunchDarkly. Get a demo at launchdarkly.com. What's up, Gophers? This episode is brought to you by our friends at Teleport. With Teleport Access Plane, you can quickly access any computing resource anywhere. Engineers and security teams can unify access to SSH servers, Kubernetes clusters, web applications, and databases across all environments. Teleport is open core, which you can use for free, and it's supported by their cloud-hosted version, which lets you forget about configuring, updating, or managing Teleport. The Teleport team does all that for you. Your team can focus on your projects and spend less time worrying about infrastructure access. Try Teleport today in the cloud, self-hosted, or open source. Head to goteleport.com to learn more and get started. Again, goteleport.com.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. If you like Go Time, you might enjoy our new show, Ship It, featuring conversations focused on ops, infra, code, real-world experiments on our open source platform. What's not to love? Check it out at changelog.com/shipit, where you'll find it in your favorite podcast app. Okay, here we go.
Hello everyone and welcome to Go Time. Today we are joined by Ashley Jeffs and Mihai Todor to talk about data streaming and Benthos. So Ashley, how are you?
I'm good, thanks. Thanks for having me on.
Well, no problem. Mihai, how are you?
I'm not too bad. Thanks for doing this.
All right, so Ash describes himself as an open source developer with projects typically written in Go and fronted by unappealing mascots. His main focus is the declarative stream processor Benthos. So Ash, what is the mascot for Benthos? Am I allowed to ask that?
So yeah, you may ask that. It is a blobfish, but I normally just refer to it as a blob because it's not, I think it's deviated quite a lot from what a blobfish actually looks like. So I just call it the blob normally, and I call Benthos users blobs.
Okay. Mihai describes himself as a seasoned software engineer focused on cloud computing, scalability, and open source Go projects. In his spare time, he is trying to study bioinformatics and is helping people organize community events such as the C and C++ Dublin meetup group. So why not a Go meetup group, Mihai?
Yeah, we had one in Dublin, but for some reason there weren't that many people joining it, sadly.
So you had to go back to C?
Well, then everything went online, and then there were a bunch of established groups that were sufficiently popular and acquiring all the speakers and such. So
Sounds painful. All right, so today we're talking about data streaming, and I want to just start sort of at the beginning and just talk a little bit about what data streaming is, why it might be useful, and then we can sort of dive into, a little bit more stuff like tools we could use for it and use cases. So does anybody want to take that question? What is data streaming?
I can give that one a try. So it's probably interesting to talk about it in terms of what's different about data streaming from event sourcing and event-based systems, since you've already had an episode on that. So in event sourcing systems or infrastructure that's kind of built around events, you're essentially using these message queue systems and passing instructions asynchronously. And that's what they are. It's like a message or a record, whatever you want to call it, but it's kind of an instruction of something to do in order to have your platform operate. Whereas data streaming is it's a completely different sort of paradigm that's ended up sort of joining with event sourcing around the same tooling now. But it's pretty much just, instead of sending instructions around, you're sending data that is sort of an asset to your company. It's kind of a product. It's important to you as an asset that you want to keep around long term, usually. rather than just something that's kind of temporal that you'll, flick around the platform a little bit and then it sort of fizzles out once everything's kind of dealt with. So the tooling used to be what we'd call batch processing based, where you kind of have like a data store somewhere that's sort of the permanent destination of all this information. And you would kind of populate it on a schedule. So you pull data from somewhere, dump it in this thing, and you would then use that thing to query the data and do interesting stuff with it. And what's kind of been happening gradually over the last 10 years or so is tooling has built up around that to enable a more real-time kind of streaming architecture with the same kind of data. So the data is still treated like an important asset. It's still a thing that you want to keep long-term, but the way that you're moving it around a platform looks a lot more like event sourcing systems now than it ever did before. But the kind of difference is in, I suppose, how important that data is to you as a company. It's something that you want to keep around potentially for, maybe months, maybe indefinitely. You want to keep this data around. So you might be flushing it in real time through a platform and doing interesting stuff with it in real time. But it's very important that the data isn't just lost or eventually it gets persisted somewhere, maybe multiple times with different versions of it, that kind of thing.
So can we put this into something concrete? Like, what is an example of where you've seen data streaming being used?
Do you want to say that, Mihai?
Yeah, I can go. So one use case, let me give a bit of background. I was working at a company called Nitro, and we were ingesting a lot of click data. And I saw this thing called Benthos online. Man, I really want to use this somewhere. And that was an interesting use case where, you get all these people who have a desktop app and they click on various things in the app and you send all those click events to the server. But you don't really want them to end up being stuck there for a while and then you do some batch processing on them. You might want to have real data analytics where you look at them in real time and you update a bunch of graphs or, can do many things with them. Maybe a more interesting use case was at another company where I was dealing with lots of audio data in real time, where you have a big call center where people are talking with customers and you want to give them some hints on the screen. Hey, you're speaking too fast, you're speaking too slow, hey, you're overlapping. And there was a system in place that could analyze the audio and using some machine learning, it could predict in real time this event is happening. And then those events would have to be sent to the operator in the call center. And that was another use case for data streaming. And this is a place where I ended up using NATs to kind of receive and send those events along. Can talk about more about that a bit later.
So these tend to be cases where actually getting some, looking at the data and doing something with it in real time is much more important than we got the data and an hour later we processed it and realized this person was making a mistake that we could have tried to correct in real time.
Right. It's also a matter of making sure the events get delivered. So you might want something like at least once delivery, and you want to make sure if the event does end up sent multiple times, you want to have some sort of idempotency so you don't confuse the users. And you don't want them to be reliable. So, making sure that things are up and running. These cases that I described kind of lend themselves to a situation where you end up or you need from the use case to actually send those events in real time. But there are many places where people just have a bunch of events from the platform that are generated while this thing is running. And they simply want to replay them back in the same order, or they want to maybe run some analytics on past data. And it's useful to, potentially not send the whole thing at once to some system and make it crunch a lot of data at a single time frame when it could be very intense. It might require a lot of resources. It might be nice to spread it out during a longer time frame.
That definitely makes sense. So, Ash, you were talking about event sourcing, and we've talked a little bit about that in a past episode. So, how would you differentiate data streaming from event sourcing? Because some of the things sounded similar in the sense that, with event sourcing, I think in my mind, a lot of the time, all those events are still persisted. So they're not that's one of the advantages, at least in some of those systems, is that you can replay them. Mm-hmm. So what would the sort of difference between that and data streaming be in your mind?
To be honest, there's a lot of overlap, and the tools are pretty much the same nowadays as well. So to be honest, it's kind of difficult a lot of the time to work on something and say whether it's data streaming or event sourcing anymore. But I would kind of say that in my mind, the way that I kind of partition them is if you've got a system where, say, you're processing a stream of orders from a website, in an event sourcing kind of architecture, you would maybe be passing those events around so that services can immediately act on those orders and do something. So, charge the customer's bank account or something and then trigger some sort of delivery. And then once that's all done, you might keep it persisted somewhere to replay later, or, maybe feed that into some test system or something. But operationally, you're kind of done with that message. It's over. It's got a lifetime. Whereas in a data engineering context, you might be processing the same feed. It could be orders on a website, but what you might want to do is something like analytics on top. So you might be interested in, okay, over the space of an hour, how many orders do we get from people who own 2 dogs versus people who own a cat? And, maybe you're going to use that to drive things like ad campaigns and stuff. So you want to have some sort of analytics built on top of that data, and you're treating the data like it's an asset. So it's an important feature of your company to have this thing lying around. And then when you've maybe done some immediate analytics, some streaming analytics to infer some important business data, you might then want to just put it in like an Elasticsearch index or an S3 bucket, and you'll keep it long term because maybe in the future you want to look back on those orders and work out what a psychopaths buy at the weekend, that kind of thing. Like just some random query that your marketing team has. It's not always analytics. There's a lot of analytics around this stuff.
Okay.
Yeah.
You guys had mentioned item potency, and I know that comes up a lot in programming. For anybody who is new to programming, I feel like that's something they eventually have to learn to handle, because it seems like almost all modern architectures are getting to the point where you have to be able to handle the same request coming in multiple times. And like you said, like not charging a person's credit card multiple times, because that would be pretty bad. Are there other mistakes or things like that that people can make when they're using a data streaming system?
I'm resisting the temptation to just roll my eyes infinitely. In queue systems, we tend to have like 2 main delivery guarantees, right? There's at least once and at most once. At most once is kind of similar to just writing over a Go channel, where you're pushing some data around, you don't really care if it's been delivered. And that works in a process because you do know it's been delivered. Whereas in networking, you have no idea. Whereas most systems are built on at least once delivery guarantees. There's exactly once, which Daniel in the event sourcing one said very well, is basically snake oil, and I completely agree with that. But then at least once systems are very rarely at least once. So I'll kind of explain what it means. So at least once as a paradigm is you're basically saying that in the event of failures, so any sort of networking problem, you will err on the side of delivering a message multiple times rather than 0 times. So the way that that's normally implemented is with some sort of acknowledgement system. So I send a message over a network and I expect something to receive it. Something then receives it, and then it doesn't end there. They send me a message back to say, yes, I've received this message. And all modern queue systems are pretty much built on something like that. Kafka and most queue systems that call themselves sort of streaming work slightly differently in that the acknowledgement is you remembering, kind of like checkpointing where you are in this sort of logical queue, because the queue is there permanently. It's not as if a message disappears. So you kind of remember where you are in that queue at any given point. So if you restart, you go back to where you were. And if you follow acknowledgement, so if you're consuming from an at least once source, so you've got a queue system that uses acknowledgement, so it could be RabbitMQ, it could be Kafka, it could be Nats, and then you're writing your data out. So say you're like a middle component in a pipeline. If you're writing data out onto another at least once queue system, it would make sense for you to call yourself at least once. It's kind of a misleading term because you're using at least once on this end, you're using at least once on that end, you're using this acknowledgement system. If it's not at least once, then what is it? But the reality is, at least once, I think, is kind of misleading because that doesn't mean you're not lossy. It doesn't mean that there's not circumstances where you might drop data under certain circumstances. And you can, there is ways of architecting your service to act that way, but that's not how most services that use at least once source of syncs work. A lot of them will behave in a way where under certain circumstances, they will lose data. But I guess one of the issues is any system that follows these rules generally, even if they are potentially lossy, will look exactly once in normal operation. It's not until you hit edge cases where, maybe all the services downstream have stopped, so you can't send the data anywhere and you run out of memory and stuff like that, or maybe it's crashes, disk corruption, stuff like that. I mean, I could talk for hours about what those edge cases are. It depends how much you want to dig in.
I mean, that's up to you. I definitely think you're absolutely right in the sense that, like, especially when we're testing code or just writing it locally, we have this idea that like we can go to our browser and visit some page that we're building and be like, oh yeah, it works. Like when there's one user and the database is local and there's no latency and all these things. And then when you push it to production and actually have like real memory limits and high usage and things like that, that's when all the mistakes come out. So I'd say it's challenging there. So how would you recommend people avoid some of those mistakes of, like becoming lossy?
So I'd say that the most common one is the idea that the acknowledgement happens when you've received the message. So you're reading from an at least once queue system and you've got a message. Logically, you can see it. That's, you've written your code so that you've got this payload and then you acknowledge it. That seems like quite a sensible thing to do, is you've received it, so you acknowledge receipt of the message. But the reality is, like, you've received the message, but you haven't finished with it yet. You're not done with that payload. So if you acknowledge the message and then immediately your service crashes, that data's gone for good, unless some poor operations person waking up at 3 a.m. knows, oh, I need to go and chase that data up and make sure we can recover it in time. So a really common one is, say you're reading from Kafka, you're committing offsets and messages as you're consuming them. Most client libraries will make it their business to make it easy for you to have like auto acknowledgement. So as you consume messages, you receive it, the offset gets kind of marked and then it gets committed on some sort of cycle. And you do stuff with that message. So you could be doing some business logic and then maybe you hit some other services or something. And then finally, if you want to preserve that data for some other services downstream, you might write that data onto some other queue system. It's a very common like kind of pipeline approach of daisy chaining all these services up. And if your service is doing auto acknowledgements, that's going to look like an exactly once system most of the time. And then if one day an operations person wakes up from an alert at 3 a.m. and they're looking at their graphs and they see that the service has restarted like 50 times in the last hour, they're going to freak out if they see that the data going into that service is more than the data that came out, if you get the aggregate over, say, like an hour or something. And it's those kind of edge cases that basically I'd sort of bake into Benthos as what I call kind of like operational simplicity, where it tries to plug all those holes as best you can. I mean, it's like saying you've got a perfectly secure system, right? You can't absolutely guarantee that. All you can do is follow what you think are best practices. So the idea of kind of like operational simplicity is you try and follow at least once delivery guarantees as much as you can and try and plug those gaps. And the idea is that if somebody wakes up at 3 a.m. because, of restarts or a service crash or disk corruption or something, they're not worried about, they can focus on fixing the problem and then not have to worry afterwards about, and now I've got to chase up, however much data we might have lost in the last hour or so. But it is what it is.
So when you're setting this up, to make sure I understand this correctly, essentially you're saying when the data comes in, you need to process it before acknowledging that you received it, so that at least once delivery is actually held true throughout the whole system. The best analogy I can think of in like a regular, like another system that wouldn't be data streaming might be like if you wrote code that was supposed to write to a database and like somebody passed the code or the data in and you immediately sent back a message saying, yeah, it was good, and then spun up a routine that went off to actually try to write the data, it's very likely that could have an error or something. So is that kind of the same, not exactly the same, but a similar analogy?
Pretty much. It's kind of, I suppose, the reason why I kind of feel like these terms are sort of misleading is because it does look, when you're looking at the protocols and stuff from kind of a beginner's approach, it looks as though you're supposed to acknowledge messages when you get it. Like that's what the protocol looks like. It's a very intuitive thing to think, you get something, you give something back, and now I'm going to continue my journey processing this thing, and then I'll send it on downstream. But if you wanted to do it properly, which, I'm not saying everybody does need to do it properly. I'm just saying that, people should probably be aware of the fact that, you ought to do this thing if you definitely don't want any lost messages. What you should do is you should read a message and then wait to acknowledge it until it's gone all the way through your service and has reached some destination. That could be that you've intentionally dropped it because, you've enacted on that message and you're finished with it. Or it could be you're passing it on somewhere else. but you don't acknowledge it until it's gone somewhere. The kind of exception to that is if you've got a sort of buffer in your service. So you might have like a disk persistent buffer. That's how a lot of log aggregators work. So Logstash and stuff is they tend to have like a buffer which is used to temporarily store the data while you're processing it. And that gives you a little bit of resiliency. And that's true. But then, if you're bothering to set up a Kafka with, redundancy and, disks replicated all over the place, why then have a, single disk as a point of failure in losing messages or not? So I don't really think that's kind of like I don't think disk buffers really have a place in sort of modern architectures, unless you don't care.
This episode is brought to you by our friends at LaunchDarkly, feature management for the modern enterprise, power testing in production at any scale. Here's how it works. LaunchDarkly enables development teams and operation teams to deploy code at any time, even if a feature isn't ready to be released to users. Wrapping code with feature flags gives you the safety to test new features and infrastructure in your production environments without impacting the wrong end users. When you're ready to release more widely, update the flag status, and the changes are made instantaneously by their real-time streaming architecture. Eliminate risk, deliver value, get started for free today at launchdarkly.com. Again, launchdarkly.com.
So for designing them this way, so that you actually act on the data before you acknowledge them, I guess, like, coming from a naive perspective, I would think if you have really long processes of some sort, like you need to take a while to act on the data, wouldn't that, or could that present other issues where like Kafka's trying to send the same message to multiple people thinking it was never received?
With Kafka, there's different problems with that. With RabbitMQ, yeah, exactly. Stuff like RabbitMQ or I think maybe NATS as well, but a lot of queue systems, especially the cloud services, have a lot of mechanisms where if you take too long to acknowledge something, it will assume it's lost and it will requeue it. So if you, say, have 30 seconds to process something and you don't acknowledge it for 30 seconds, because that's just how long it takes your service to run, then you have a problem, because then you're essentially increasing the size of your queue potentially indefinitely, because you're just not following what they consider to be best practices, which is to extend. What you should be doing is you should be extending your lease, I suppose you could call it. They've all got their own kind of terms for this sort of stuff, but any system that will automatically requeue a message usually has some mechanism for temporarily saying, hey, I'm still working on this, by the way. Or at least you'd be expected to have a kind of like finger in the air guess as to the maximum amount of time that you're likely to be processing a message, and then you just configure it to not requeue things outside the time. But that's less ideal because that doesn't take into account things like back pressure. But yeah, there's definitely issues with doing it. There's lots of weird things. But then the is on the side of duplicated messages and everything kind of grinding to a halt rather than data being lost kind of silently. So in my opinion, that's the better option, but it depends on your system.
I assume your system grinding to a halt is also way more obvious than like a couple messages getting dropped and nobody realizing it until they go back later and look.
Yeah, so Benthos loves grinding to a halt. That's its default, basically. If something doesn't look right, I will stop. You will have to tell me what to do. So if you've got a message that you just can't send, maybe it's too big, and you just can't send it to Kafka, then it will just wait. It will just say, okay, I can wait all day. Come and, tell me what to do.
So we've talked about a couple different tools. For somebody who's coming into this and they don't really know a lot of the tools, can you sort of explain what some of them are and why they might be used? Like we've talked about NATS and Kafka and RabbitMQ, and you've mentioned Benthos, but like how do they all sort of work together?
So those are the queue systems. You got Kafka, NATS, RabbitMQ, all that stuff. There's lots, and they've all got their kind of specific use cases and operational complexities, which does factor in. Then you've got stuff, what happens on top. So there's things like Spark is probably, I think if you're talking about data streaming, Spark is going to come up. And then there's similar systems to that, like Flink, I believe, is pretty much the same thing. And cool stuff like Materialize, there's KSQLDB. Those are tools that will essentially solve a data engineering problem on top of that stream. And it's usually around some sort of like aggregation in real time of the data. So you imagine with a data set, you used to have, a fairly static collection of messages, and you were used to doing queries like how many of these people are happy proportionally. And that's a fairly simple task because you've got a static data set, so you could put it in a database or whatever. But when you've got a streaming data set, something's coming in real time, it's a lot more complicated now to give you an answer if you want it in real time. And that's the whole point of a lot of these people setting these tools up. So what it ends up being is a system that kind of sits on top of a queue system, and you essentially give it some sort of aggregated question to answer. So it could be like a rolling count of how many people made purchases in the last hour or something versus leaving the website, stuff like that. And they're kind of tools that are programmed, like you build them. But the way that I see it is they're kind of similar to machine learning tools where it's not as if you're writing a real program. You're kind of using code to describe what sort of aggregations you want, and then it's clever enough to go and do that. And it solves all the hard problems like distributed processing, which means, it's in memory processing, but it's on a data set that's so big you can't process it on one machine. So to scale it, you have to do sort of sharding of the data and all this crazy stuff, and you've got to do windowing. So if you're getting back some sort of like aggregated number, then it's got to be with respect to some sort of measure of time. And then that's kind of like, those are the tools that do very, very cool, complicated things. Shout out to Materialize as well. I'm checking them out at the moment. That's the system that's built on Postgres. So you imagine you've got like rolling Postgres queries on a stream of data, which is pretty cool. But then the other side of data engineering is making that data what you want it to be. So kind of, I would describe it as plumbing. So, you've got Spark and stuff which are making useful calculations on the data. And then your data team probably also wants to do things like maybe you've got like a comment on an article, and that's coming in as a stream of data. And what you want to do is you want to make that data more useful by adding information on. So, we call that hydration. So maybe based on the ID of the article that it's commenting on, you might want to go and grab the article, and maybe you want to pull stuff out like, what is the article about? Who does it mention? Things like that. And then pull in user information as well. How many dogs do they own? How many cats do they own? And what you end up with is this much bigger piece of data, but it's much more useful. So when you put that in an index or some sort of data store, it's just better. And that used to be something that was done in a batched way. So every day, maybe you'd kick off a process that does that. And now we've kind of got all these tools that let you do that in real time. So if your data volume is so big that you can't do it in a batched way, you can do it as this continuous stream of data. So the stuff that I kind of specialize in is the tooling that plumbs all those different services together. So you can read from multiple streams, you can multiplex them out to different destinations, and you can, on the way, you can hit all these different services and mask the data and enrich it with all this different stuff. And then the core premise is that it's YAML programming. It's not a language that you have to compile yourself, which means you can give it to somebody that isn't perhaps as specialized in code or does code, but they just don't want to do that kind of coding because it's kind of boring, all this plumbing work. So they would rather just deploy a tool that kind of deals with that stuff for them. And there's a lot of repetitive tasks, a lot of CRUD apps and things built on top of this stuff. So that's kind of why I ended up building this tool, is just sort of a general solution to that kind of stuff.
So I got to ask, don't you feel guilty about introducing more YAML to the world?
I love YAML. Oh my God, I love YAML. I could couple up YAML all day. I have to say Q is on my radar. I'm loving what I'm seeing from Q, and I think that's probably going to... I've built a lot of tooling into the app, into the program, so you can, it's lints files, and it's got a solid schema and all that kind of stuff. So hopefully it's not horrible working with YAML with Benthos, but there's a lot of stuff that Q could possibly solve as well on top eventually.
I'm just kidding, because you see all the people using like Kubernetes and everything talking about how they're basically YAML developers at this point.
I see a lot of YAML hate, and I see a lot of YAML love. But yeah, there's definitely a lot of YAML programmers now. I'm a YAML programmer. Not afraid to say that. I love a bit of YAML. Hopefully something better eventually.
Actually, I just on JSONet a bit recently, and it's not too bad. I guess QE is more interesting, but with JSONet, there's already a bunch of stuff in the open source world you can use and compiles. It's easy to kind of get code generated from it. Helps with maintenance and drying up your code. You just don't repeat yourself so much.
All right, so I guess my next question would be, let's say I'm interested in trying out Benthos and setting up a data stream. What are some ways that in a common application somebody might actually be able to take advantage of it? I don't know if there are any that you can think of, or is this something where like you need to be in a large enough setup for it to be useful?
Oh no, I mean I'm using it for all kinds of stuff, and I don't really work. I think, like I kind of said at the beginning, there's what we're kind of seeing at this point is that a lot of event sourcing tools are becoming very, very similar to data engineering tools, and they're all kind of crossing over. But Benthos is super general, and because of the types of problems that it solves, you can end up using it for all kinds of stuff. So like some of the stuff I'm using it for is I run it and it hits the Homebrew, Docker Hub, and GitHub APIs to get the download data for Benthos, and then pulls that down, and then it can send it to me however I want, but you can send it to Discord. Like Discord is an output now. I built a Discord bot with Benthos, and there's a little cookbook on the website, so you can build your own, or you can join the Discord and interact with it yourself. But yeah, you can do all kinds of stuff. I mean, you can hit like HTTP APIs. Say you hit an HTTP API, or maybe you consume tweets, and every message that you receive, maybe you hit some other APIs, maybe you put it into a database or something, and then you can mutate it in all these ways. It's got mapping language, it's got all this kind of general purpose tooling for manipulating data. It's totally agnostic to what you're using. So you could be sending images around, doesn't really care, or it could be JSON documents, and then you send it to somewhere. You could be using it to just populate Grafana dashboards. So I use it for that as well. I just pump out Prometheus metrics for various things. But yeah, I mean, if somebody wants to play around with it, there's lots of ways of using it for very boring tasks, because that's what it's for, really. It's for very boring, basic things.
So like when you mentioned the Discord bot, I assume it's going to be something set up where Benthos handles the stuff of getting the messages from Discord and sort of streaming them to you, and you essentially just have to make whatever reaction or do whatever you want to do regarding that? Or like, how would that look?
I don't want to give up too much to the special sauce because I don't want to ruin people's interaction with the bot. It's magical as it currently exists. But basically, it's reading a continuous... So the input is just polling the Discord API for messages. And then what I've got is in the Benthos YAML config format, I've basically got like a load of... It's basically a switch case expressed in Benthos land, where you can have these like little mapping queries to dig into what the message contents are. So it's got some pre-canned responses. So you can do things like /joke and it'll tell an awful joke, and /roast and it'll roast you. And then there's some like special responses it has particular commands. But then the other one is it also reads from a separate channel that's only visible to me. And I can type messages in that channel and it will echo it into the general chat. So it basically acts as my voice. It is a stream. You can think of that deployment as a stream of data because it's reading from a Discord channel as a continuous stream of data. And then it's writing a stream out, which is spewing messages out into the general channel. So, I mean, it fits the paradigm. I mean, it's not data engineering, I don't think by most people's standards, but like you can use the same tool for this stuff because at the end of the day, all you're doing is moving data around and manipulating it in certain ways. So it just kind of fits in a lot of use cases.
So you're saying if I want to pretend like my company was really big and I had like 10 support agents, I could just set it up so I could just have my own channel privately and have them respond like they're a different person.
Don't give away too much on the stream, but yeah, you can do stuff like that. You can DDoS people. I'm pretty sure I've DDoS'd people accidentally with it.
Accidentally being the key word there. You're like, disclaimer.
Yeah.
Totally an accident.
Can we cut that bit?
It's one mean bot. Like, it's very, very mean to you.
Sounds pretty...
But actually, speaking of very mundane tasks, imagine even like large file transfers. If somebody has a whole bunch of data in a legacy data source and they want to put it in the cloud or do something with it, like, I don't know, gigabytes, terabytes of data, you can use Benthos for that, and it works pretty well. The thing to keep in mind is that you shouldn't aim to like put 50 gigs in memory and then transfer it somewhere else. That just doesn't work. So what we end up doing is chunking it. And like right now we're using an arbitrary chunk size of say 50 megs or whatever. But it kind of has downsides as well, because if it's binary data and you just chunk it like that, then you can't really do much with it while it's in flight. Whereas if it's some sort of structured data, like let's say JSON or CSV or whatever text format, then you can also potentially profit from the fact that it's in flight. You're transferring it, but you're also modifying it, like maybe enriching it from some other third-party source or modifying various issues in it that might help people who are working with it later on to do their work better, or various boring tasks that are very much needed in big companies.
I'm always surprised and scared by some of the things people are doing with it.
Yeah. Now, right now, quite a bit of my work is like adding adapters and such, so we can, plug into various legacy sources and have those stream to other places.
Oh yeah, that's something to mention. It's got a super cool plugin API. So you can write your components in Go pretty much using the same API as the native ones do.
What's going on, Gophers? This episode is brought to you by Equinix Metal. If you want the choice and control of hardware with low overhead and the developer experience of the cloud, you need to check out Equinix Metal. Deploy in minutes across 18 global locations from Silicon Valley to Sydney. Visit metal.equinix.com/justaddmetal and receive $100 in credit to play with. Again, metal.equinix.com/justaddmetal.
Plugins are always like an interesting topic because I feel like in different ways people sort of implemented them differently. Like at one point we talked with Mark Bates about how he did plugins for, I think, Buffalo. And I think he'd gone through like 2 generations of it to try to figure out like what made the most sense. And I think it ultimately became like a single method interface that you just had to implement or something.
It's very similar, but yeah,
Okay.
You have to bake it in. There's no like dynamic plugins to load it runtime. You have to compile your own version.
Okay. Is there anything else about Benthos that we should know at this point? I'm coming up with a blank as to what to ask you next, and I feel like you would know. What are some interesting things people would like to know about it if they're going to give it a shot or try it out?
Just look at like literally. I think the thing about it is it's pretty much just it's not going to be as dynamic as just writing code. If you want to do something, then do it. Like I'm not a big user of frameworks and stuff. In my opinion, if I was going to write a bespoke service for reading from a particular thing, I would probably just use the direct client libraries because I just feel like that's usually the go way and it's what I prefer. But I think that when you see what the config looks like for certain things, like you can, you imagine you can read from like 3 different queue systems and do some mapping on the documents conditionally. And then you can write it out to, several different places multiplexed by the contents of the message. And that's like 20 lines of config. All you have to do, I think, for most people is show them what the config looks like and they'll know whether or not it's something that they're interested in. Because I think if you don't have to deal with a lot of this stuff often, it's probably more fun to just write the code and not use something like this. Whereas if you're sick of solving the same problem over again, like we've written a RabbitMQ consumer that writes to Kafka and removes the field foo, and then we've got another service that reads from NATS and then it writes out to an S3 bucket and it targy zips the files. If you've written that same app a million times and you're getting fed up with it, then it's for those people. It's people who use that kind of people who are in that space and they're sick of working on the boring junk that they're being asked to do by their data science department, and they just want to work on fun stuff.
Okay, so basically if they're in the position where it would make a lot of sense, they'll realize it because they'll be like, I'm so tired of doing this that I want to throw my computer out the window.
But the thing is as well, I feel like a lot of people just don't realize that there's tools out there that can make that stuff easier. I think that's the problem I'm kind of in now because I don't want it, like it's sort of organically grown. I made it out of kind of a defensive position of I wanted that tool for my own purposes. And then, the more people use it and then it kind of grows organically. And I've not really marketed it that heavily beyond just putting really wacky stuff out on Twitter. So like, it's not, I've not done a massive job of putting it out there, but I feel like a lot of people just don't realize there's tools like that. And they take a while to trust it as well, because the main selling point of this product is that it looks after your operations people and prevents them from having massive panic attacks at 3 a.m. They just have a minor panic attack. And you can't really, it takes a while to get people to trust that.
Yeah, trust is important. Yeah. Like I'm talking to a bunch of bioinformaticians and they're not aware of this, of course. Like they have their own way of doing things or ways. And just getting them, hey, there's this, nice bloblang DSL that makes a lot of this work that you're doing very easy. Imagine there's a bunch of like JSON APIs out there that have a huge volume of data and they might want to like extract stuff from them, like maybe query something for a certain gene, or do some sort of cross genome analysis or whatever. And in those cases, yeah, you can write your own bespoke tool, sure, or you can use something that is like more traditional, like Spark or whatever. But you can certainly explore other tools as well, and that's something I'm trying to promote, and hoping to see some users there as well. Also, this is open source and free, and by far this is one of the most responsive projects out there. Like, sending a PR, getting somebody to like review it in a few hours. It's not that common.
It's like that for now, until I get bored and move on to something else.
So I guess that sort of leads us into unpopular opinions.
I actually think you should probably leave.
All right, Ash, do you want to start with your unpopular opinion that might upset everybody, or the other one that's more related to Benthos?
I'll go with the one that's going to make everybody shut the stream down immediately. People who vote in Twitter polls are losers, and they should get out more. Nobody cares about your opinion. It doesn't matter.
That's harsh. I don't even know where we go with the discussion for that one.
Harsh but true.
I feel like hiding under the table now.
Do you vote in Twitter polls?
Sometimes.
Has anybody ever cared about your vote? No.
Sometimes you just want to see the answer.
Sometimes you just want to see the answer.
Data.
Yeah.
I just like to ruin their stats, like throwing a curveball in there.
Can I just clarify? Because I think there's a lot of people upset out there who need not be. If you're voting in Twitter polls because you want to see the answer, you're not a loser. You probably do have a life, and you don't need to get out more.
I don't know if that necessarily helps that much. All right. Your second unpopular opinion. Can you share that one?
Yeah, so as an open source author, I think I probably get to say this, but I kind of feel like there's been a lot of noise, well, not noise, meaningful articles, meaningful stuff out there, people who kind of write open source projects and the fact that businesses kind of rely on them and they don't contribute back, and it's not a particularly healthy ecosystem. Personally, I think open source is a form of business. And I think that a lot of the discussions around open source ethics and how we should model things, I feel like doesn't kind of follow that logic. But I kind of see it as like, I feel like as software engineers, we tend to see businesses as rapid growth, funded, massively huge corporations that are designed to dominate the planet. But the reality is most businesses are very small, maybe just one person, two person organizations. Maybe they're a dry cleaners, maybe they're a pie shop. And I feel like open source is very, very similar to that, where you're not necessarily making money directly at this point. You're just trying to grow something because you enjoy working on it. And there is a prospect at some point of maybe making money from it and, turning it into a living and growing it. But I feel like we don't really treat open source developers like that. We tend to treat them like they're either this big corporation that I can use as much as I want and not give anything back, or we see them as kind of like charity cases. And, GitHub sponsors is great. I feel like that's a great avenue, but I don't feel like it's the only one. I don't think we should be treating everybody who's working in open source as if they're a charity case and that we need to rescue them necessarily. I feel like we should be seeing them as people who have lifestyle businesses, and maybe it's going to grow, maybe it doesn't. I feel like there's a lot of projects that are very akin to, maybe a niche burger joint in San Francisco, and then overnight they're a social media sensation and then they're feeding the entirety of San Francisco and they just can't cope with it, and the business that they really enjoyed working on is no longer enjoyable. But we wouldn't say the solution to that is to throw donations at them. The solution is, I don't know what the solution is. I see open source as kind of like a business light.
I mean, you could easily look at it as open source is by default an unprofitable business with everything given away, like they're just selling everything for free. And if you view it that way, I completely agree with you. And I think most people who build open source projects have this idea of, at least in their mind, they want to do something to make it profitable enough that they can at least continue to work on it as long as they enjoy it. But at the same time, I completely agree with you that the community doesn't always like to acknowledge that. Like, I remember when Caddy changed their licensing, there was like a huge outcry over that. And like the code was still open source and everything, but they were already talking about forking it and everything else.
Yeah.
And I completely get why they were doing it. They're like, we have this big popular thing and we don't make any money off of it, or like not enough to sustain really. So in that sense, it is kind of weird that we rely on it so heavily, but then get so weird when people try to treat it remotely like a business.
Mm-hmm.
I guess I'm also like, I'm on your side on that one, just because I've done a little bit of open source stuff, and I have courses that teach programming, and I've kind of had to base it around the similar model of like some things are free and then some things are paid. And I feel like that's one model that works for open source, but it definitely doesn't apply to all open source. Like, I don't know if you could do it with Benthos or not. I really don't know, but there's some open source projects where it's really hard to like take away and make something paid without like completely ruining the product.
Yeah. Yeah. Okay, maybe go with my first unpopular opinion, because that one maybe doesn't seem that unpopular.
Well, that one, I think it's going to depend, because I think people who have written open source will probably resonate with it, and people who have not written open source might be like, no, they're not businesses. They're supposed to give it all away for free as like a humanitarian act or something. I don't know. I have mixed feelings there with some people, because people generally tend to expect the world for free.
But I feel like as well, there's a lot of open source maintainers who don't like the idea that it's kind of a business, because they don't like the idea of these like super funded like mega corporations and exponential growth trajectories. But you know, that's just a small business. Like, you wouldn't go to the dry cleaners down the road that's like a 2-person family owned business and expect them to get VC funding and then, you know, hire 100 people in a year. They're doing it because they enjoy that. That's their thing. They enjoy the process, and, you know, their goal is to make a living. It's not to grow and dominate the planet with their superior dry cleaning.
I mean, it's probably hard in the sense that like the dry cleaning example, they can choose not to open up new locations. Whereas like open source, you can suddenly have 1 million users and not know how to handle it. Because like Mihai, you mentioned that Benthos PRs are answered really quickly, but at the same time, there's a lot of projects where people get overwhelmed and like people don't structure PRs correctly. And after a while, it's just like, I'm spending 10 hours a day just trying to, you know, correct things when people are submitting bad reports and things like that. So it's like, then it gets exhausting, and there's not really a filter there. Whereas like with a physical location, you can limit it to be like, we just have one. We aren't going to open a second.
A burger stand, if somebody tweets, if somebody gets a good tweet, a burger stand that was perfectly happy one day could be miserable the next, with like a 2-hour queue and angry customers running out of condiments.
So you're right, but there's also a cap. Like,
yeah,
at the end of the day, like they can say we're open from these hours, and when we run out of burgers, we're out of burgers, and that's life. Whereas like open source, you could have bug reports pretty much infinitely, as long as there's people on the internet to find it and file reports.
I guess it's like Benthos, right? If you hit it too much, it grinds to a halt, because it just doesn't scale horizontally that much to have a proper, I don't know, center of competence of maintainers who can process all of those at the same time. So I guess things will start stalling at a certain point if the volume increases.
but also if my local family-owned dry cleaners shut shop one day because it's just too much for them, they're getting a brick through their window.
You're very kind.
I need my dry cleaning.
So I don't think I own clothes that need to be dry cleaned, but I've also worked from home for like 7 or 8 years. So I have like one suit, and it's like my wife had like wedding season with her friends, and I'm wearing the suit all the time. And then like the next year I don't wear it at all. So like during the wedding season, I'm like, maybe I should get a second suit. And then once it died out, I'm like, no, I don't need a second suit.
Yeah, but when you do need it, you need a dry cleaners to get all the dust out.
That's true. But aside from that, I don't go dry cleaning very often. But okay, so if you're looking at these open source projects as a business, can I ask, how does that change the way you look at like Benthos?
So, yeah, I mean, my first goal with Benthos was to just get to use it at the place where I currently worked, or rather I worked at the time. And, you know, the idea that I could solve this problem that wasn't really being acknowledged at the time, and it was open source. I'll put my time into building this solution out, since, you know, we're not going to be doing that as part of our job. But then one day, if they do adopt it, I'll get dividends by, you know, being paid to work on my own little thing. And then if I change organizations later, I can bring it with me. So, I mean, That bit is kind of, I suppose it's not entirely like a business, but it kind of is, because you're sort of starting a side company hoping that your company is going to start using them, basically. And then all I really wanted was to be able to work on it to some extent. And then once that happened, I was like, well, okay, more. I want more of that. I want to have more time to work on this thing and also still be getting paid. And then it's pretty much just like stepping stones doing that. And, you know, it's not always like immediately obvious what the next step is, but you're pretty much building if I was braver, then I probably would have just quit my job and worked on it full time with no pay. But also I'm not like that. I like to have a living and take things slowly. So for me, it's been sort of like a gradual thing, but you kind of consider it as sort of like, I guess, moonlighting a separate company. It's just not obvious where the money is going to come from.
Did it cause you to like think about it in the sense of like, how am I going to make money? Like, did it cause you to think about putting certain features behind like a pay gate or something like that? Or was it more just like a little bit different? I don't know.
I think to me, so obviously there's business models for open source where you're able to scale it and grow it massively in a short space of time. So with stuff like that, with that kind of growth, you need to have something specific to make that money from. You need some sort of channel. Whereas I think if you're happy just being on your own and making potentially just enough to get by yourself, then you don't need to do any of that stuff. You can just do support. It's not the best way of funding an open source project with the support model, because it does kind of put you at odds with the project's goal. The project's goal is to be easy, and support is kind of the opposite of that. But if you're only interested in keeping yourself going, then there's not really any conflict, because I can make it incredibly easy. There's going to be a few people who still want some extra stuff on top or help with it. So I've obviously had to think over time about how I would fund it going forwards if I wanted to expand it. And, you know, obviously I'm in that mindset now, because that's kind of why the next steps are. But to be honest, I'm quite happy just carrying on like this. I mean, if somebody told me like, this is your life now, basically, I'm essentially just a consultant around the project. And somebody just said like, you're never going to do anything other than this your entire life. And I went, all right, okay. Sounds like I retire at some point, but that's fine.
I mean, I do, like when you mentioned support, I think there's at least some of the models I've seen that seem to sort of go with the support, but not quite exactly support. Like what's coming to mind is Tailwind, which has, I don't know if you've ever used it. It's a UI CSS framework, but they have like a paid version, which is like pre-built components. And I guess like one of the ways I could see people supporting is kind of like, you have it on the website actually for some of them, like the cookbooks of like, here are different ways to build some certain things, and like some pre-designed ones, which to me is well beyond like, here's how you use it and here's like the basics of getting started. You could actually have like pre-built things like that of like, here's a really common setup we see, and you know, here's some code that already works for it all. You're welcome to use it, and you just have to pay for it or something. So I guess what I was bringing that all up to say was I view that as like kind of a support model, but it's not really like a making it harder to use one. It's more of a, we'll do some work for you and provide it for you, just to make your life easier.
So you could definitely get by with stuff like that. Like, I mean, I wouldn't bet 1,000-person company built around that model. I mean, you could do it. I just don't think it's like the most ideal setup for that kind of business. But I mean, for one person, like, it's not, you don't need to go that far. You know, I just need to get by. I just need to be able to buy my magazines and get my dry cleaning every week, and I'm happy.
There's always going to be a need for some sort of custom adapters and such. There's always like plenty of legacy sources, legacy whatever, or existing things that, you know, like it might be nice to have everything in Benthos, and then Benthos is like the kitchen sink of all the sources and things, but some of them just don't belong there. Like, I don't know, maybe somebody wants a Sybase adapter. Like, who cares about Sybase?
But yeah, like, it's infrastructure as well. So lots of people essentially build a business around it. And then, you know, if they want support for it, they're willing to, you know, pay up, because even if they don't really need an awful lot, it's more they want to support whatever I'm doing. Basically, is we want you to carry on doing that thing indefinitely, please, because our business is pretty reliant on it. But yeah, I'm not struggling.
Yeah, that makes sense. It definitely seems like people are coming around more to intentionally trying to support the open source code they use. Mm-hmm. And I'd hope that continues, because it seems like something that if it went the other direction, that open source would very quickly just sort of fizzle out as something that's not really doable. All right. I was going to ask Mihai if he wanted to share an unpopular opinion.
Well, I didn't have anything specific related to Benthos, but I'm always happy to rant about the fact that I just don't accept being grilled in interviews anymore. Like technical, go to the whiteboard, do an algorithm. That's just not happening to me. I had plenty of that in the past. It always ended up like some sort of miserable failure or just came out very unsatisfied out of it, and took it on myself to just have this very public stance on it and just say, no, I'm not doing it. If anyone contacts me and says, hey, we want to hire you, okay, what does the interview look like? Does it have this algorithmic test? Bye.
I guess my first question would be, do you think you could have done that before you were like a seasoned developer?
No, it's certainly a privilege. Like, of course, I can do it right now because I know I can find a job easily without having to put myself through that. But yeah, I definitely sympathize with people who are just starting and they definitely can't avoid this. And I'm hoping that, more companies are going to realize that it's like a leaky bucket where you're going to get maybe a few people, but there's going to be those few people who just don't fit well to this interviewing style. Like you're going to get some people who just get very nervous and they're going to end up failing miserably, although they're probably going to do a good job as a developer. That's my take on it, honest.
How does that affect your process for finding if you're looking for work or a job? Like, is it just asking recruiters or whoever you're talking to what the interview process is like, or do you actually like actively avoid certain companies? Or
yeah, I definitely avoid like top FAANG companies. That's they have protected that kind of mindset of interviewing people and they don't want to change it. That's fine. I don't want to work for them, or I don't anymore. I tried and that didn't work out well. But like it takes maybe a kind of a different mindset. You have to like keep a very open mind and say, hey, I'm willing to do other things that are, maybe just as good to evaluate my skills. Like some people are going to be happy to let you code something in your free time, or they might say, hey, maybe you can go to this open source project and contribute something. And, based on that contribution, they're going to be happy. Or they might just be very happy to talk about, some architecture and have you design that on the board in front of them. And that's usually, at least for me, it's usually way better than going and writing code. But it's all about flexibility and finding the people that are flexible and looking at non-standard sources for jobs. Like many people are just going to be like, I put up my profile on LinkedIn, I put up my profile on these two other sites, and I'm expecting people to contact me. I'm usually more proactive than that, so I might go on Twitter and like stalk a few people who are looking for jobs and see who replies, or there's a bunch of Slack groups where people are now advertising various niche jobs, and that works much better.
That makes sense. Like you mentioned a couple different processes that you can use to sort of evaluate skills. Is there any that you prefer, or like the ones that you think make you, I don't know how to phrase this, like as the interviewee, are the ones that you really prefer that feel like they showcase your skill set best, or?
Yeah. So I'm in a position where I get to like evaluate people sometimes. And personally, I do prefer to see some code from this person. I know many people are, there's people who, probably most developers out there have never really written any open source code and they don't have like any big project to showcase. But personally, I would still like to see some sort of small example. I'm pretty sure like if they have like at least 10 years of experience, surely they wrote some small script at home that they will be okay to share and, show something that kind of works and is like decently well written. And I'm kind of particular about seeing well-structured code. Like, again, kind of to promote Benthos, like seeing the well-structured code in there, it just makes me happy. Like I'm happy to contribute to that code. It has a certain level of abstraction and maintenance and so on that is not hard to, it's not easy to see in other places. Like there's quite a lot of internal code in many companies where I worked in that is just, impossible to maintain going further. It's just legacy by default ever since it started. And kind of trying to avoid that. So, ideally, if I get to hire people, I would like to hire somebody who pays attention to detail. And that's something that I appreciate in a company. If I see that they care about this when I go interview with them, then that makes me happy.
That makes sense. I know that problem is usually a very tricky one in the sense that, like, I agree with you that algorithmic interviews don't showcase a lot, for at least for everybody. Like, there are some people who are going to thrive with those, and there's others who are just never going to do well with those, even though they might be great engineers. But I know there's also countless people online that I've talked to who are like working a job where they can't basically share any of the code from that job. And sometimes the way basically the agreements they had to sign with the company are set up, it makes it really hard for them to do almost anything outside of that. And I've seen some companies that when they do the interviews, they're like, well, we'll do like a 2-hour paid project. But then if you're working somewhere, there's oftentimes a term that's like a clause that says you can't moonlight for somebody else. Yeah. So like there's all sorts of troubles there. And it's not an easy problem for sure. But I agree with you that being flexible is definitely useful in the sense that the way I'd put it is I don't necessarily think they should be banished entirely. Like if somebody really prefers to go that route, then cool. But I definitely agree that forcing everybody to do it is kind of silly because pretty much every senior developer you'll talk to has been like, I haven't touched that stuff in however long they've been working professionally, pretty much.
Yeah, I mean, the secret is to be flexible. And I do see the merit of like helping people who just cannot afford to spend more than, 5 hours interviewing or whatever. And that's fine. Like, I'm pretty sure there's plenty of companies who are going to go with that and, everybody's going to be happy. Just make sure you don't like make it impossible for people like myself to find a job.
Hopefully that doesn't ever become the case. Generally speaking, I feel like once people have worked long enough, it, like you said, you get kind of privileged in the sense that it's a little bit easier to find work and you usually have peers that you can leverage that helps. But for junior developers, that's a tough problem. I think I just recently saw a tweet that, I forget who it was, but they basically said if you think it's hard to hire senior developers now, wait 10 years and when nobody's been hiring junior developers for 10 years.
So I'm actually surprised how many people don't even ask, like you have somebody who just graduated from university and they come in for an interview. They are not asked, hey, do you have some project from university that you'd like to share with us? No, just here's the algorithm, solve it. Okay, you solve the algorithm, you're hired. Why? It's kind of a missed opportunity. I mean, you get to see more of that person if it's possible. If not, that's also fine.
Yeah, the worst part for me was in university, almost all of my side work was on a programming team, which did algorithmic type problems. So like, even if I had side code, it was pretty much all that. And it would have been like, oh yeah, go look at Topcoder and like the thousands of problems I did in my spare time. But it's also weird because that code is like, looking back at any of that code, I'm like, this is not at all useful in like writing sustainable code because when you know your whole thing is going to be 100 lines of code, sustainability is irrelevant. You're just like, yep, globals are fine. Throw them everywhere.
Yeah. Well, that's why some companies, like in Plugin Optum here, they have this program where we get people who are really new. Like imagine somebody who might have a 6-month boot camp and they don't have a formal training in CS. They come in and they're not really expected to deliver anything like substantial. So we give them a lot of time to, hey, just go through documentation, build something that you like, kind of something you can show or something you can talk about and reason through in detail. And that's a process of learning. I hope that, we're not showing them only bad code.
All right, Mihai, Ashley, thank you for joining me. I guess I probably should have called you Jeff there.
Don't. Thanks for having me.
Thanks for having me.
We have a bunch of podcasts for you to go get on changelog.com. If you need a place to start, I personally recommend episode 450 of the Changelog, Why We Love Vim, and check out episode 451 while you're at it. That one's about modern Unix tooling. Of course, the Galaxy Brain move is to subscribe to our master feed and dry up that podcast app. It's all Changelog shows in one easy place. Check it out at changelog.com/master or just search for Changelog Master Feed in your podcast app. You'll find it. Go Time is produced by Jared Santo with music by Breakmaster Cylinder. We are brought to you by awesome sponsors. Thanks to Fastly, LaunchDarkly, and Linode. Next time on Go Time, John Calhoun returns and he's invited Matt Holt to the show to discuss Caddy version 2. We'll have that ready for you next week.
Change